Hello guys, in this video we are going to talk about layering in computer networks. With that, we will be talking about layering architectures. There are two of them, that is OSI Reference Model and TCP/IP model. Alright, so let's begin. Well, first of all, layering in computer network. Why there is a need to do layering? What is layering and why do we do it? So basically, layering is decomposing the problem into more manageable components, that is layers. Now suppose you have a huge problem. Now just you have just a section in which you can be facing problem regarding the IP address is not correct. I'm just giving you an example, like regarding problems regarding IP address, regarding MAC address, regarding port address, and entire problems are just in one section. Now when you try to find out the section in where is the problem existing, then you're going to find just that just there is the problem and you have to go through each and everything. In order to make a troubleshooting easier, that is, whenever we are facing an error, in order to make facing that error easier, in order to make solving that error easier, we have decomposed that problems into 7 different layers, or how many of the layers are there may be, we have decomposed them into different layers, so that if you have problem regarding one section, or if you know that this section is not working properly, you probably are going to have a good idea of what could be the problem, or how basically you have to focus towards. So this is the main idea, to manage troubleshooting, make it easier, and to provide more modular design. Okay, this is layering. Now we read what is layering and why do we need layering. Moving on to, look, protocols in each layer governs the activity of the data communication. Now each layer, but I am going to discuss with you later on, it will be having its own protocol, own rules, how to do the things. Basically this means that how do I will do the things. That will be it. Now what are layer architectures? So there are two types of layer architectures, OSI reference model and TCP/IP model. OSI reference model means open system interconnection. Today we are going to read about this model. What is this model and everything about it, I'm going to tell you. Now look here. This is not a protocol. This OSI model which I'm going to tell you, it's not a rule that will govern you, that will tell you how your data packet should reach the other end or which route you have to take. Nothing like that. It's not like that. It is only a guideline and hence is referred as OSI reference model. It is only a guideline that has been meant for you so that you are able to use that. Okay, this is the way I have to arrange my things. It's just a guideline. Alright. Now, International Standards for Organization ISO developed this. Purpose is to let two different operating systems interact with each other without requiring changes in the logic of hardware and software. Suppose you have MacBook and the other one has the Windows. So how will be they able to share data without having some specific changes in their hardware part or their software part? This is what the purpose of creating a basic OSI model was. Now this model was not actually fully implemented, never was fully implemented, because this was actually implemented. This is transmission control protocol, internet protocol. Okay, this is what actually internet uses. It is a hierarchical protocol made up of interactive modules, each of which provides a specific functionality. Today we are going to basically talk about this one, and we are going to elaborately talk about this in the next session. So let's just jump to what OSI model layers are. So there are basically 7 layers. I told you about layers, right? That there will be some layers in which we'll be dividing the problems that troubleshoots the different sections into different layers, different responsibilities into different layers. Alright. Now, we have ranked or numbered the layers from lower to upwards. That is, the last one is layer 1, the above it is layer 2, then layer 3, then layer 4, layer 5, layer 6, layer 7. So if you look at this way, then the first one is if from the look at this from upper to lower, then it will be the first one is application layer, second one is presentation layer, the third one is session layer, then transport layer, then network layer, then data link layer, then physical layer. What application layer will do is application layer is actually going to get your data, your actual data. You are sending an image, so that is a data. That actual data is provided to this lower layers by this application layer. Then presentation layer is going to encrypt that data so that no other person is able to understand what you are sharing. This third layer is going to maintain a connection. Then transport layer is going to add the IP addresses. The transport layer is going to add port address. Then network layer will be adding the IP address to all the data that they produce, these upper layers produced. And then this network layer added the IP address, right? Now whatever was produced by all these layers is going to go to data link layer. Here the MAC address is going to be added. Then at last the physical layer will convert all that data into electrical signals, you can say, that is from 0 to 1 to electrical signals, and then we'll share it via wired medium if it is, or in the form of waves if it is a wireless medium. So let's talk about these layers in detail. First one is application layer. Now this enables the user to access network resources. Services provided by application layer are file transfer. You can sending messages on WhatsApp, access management, then mail services like email and directory services. These are the services provided by application layer. Then presentation layer. Presentation layer basically does translation, makes the common format. Suppose you are talking in English and your friend is talking in Hindi. That other one does not knows your language and you somehow does not knows his language. Now can there be a communication? Of course there can't be a communication, because if you are talking in another language and the other person is talking in another language, how you both will be both are going to understand each other? Certainly you are not going to understand each other. So you have to talk in a common language in order to make a communication successful. That same case is with these computers. They have to first agree on a common format, then they will be able to communicate. Then this was the first thing that presentation layer does. The another thing is encryption. As I told you earlier, it's going to encrypt the data, that is kind of changing its form to prevent others to see it or understand it. Rather saying to prevent other to understand it. Only you will be know how to decrypt it. The third one and the last thing it does is compression. Alright. Coming on to session layer, it establishes, maintains and synchronizes the interaction among communicating devices. Now dialog control is a thing that it does. There is communication among two processes in half duplex or duplex. So it's going to manage that. Then synchronization. What synchronization is? Basically it's going to check if you are sending, suppose you're sending a file of 100 pages. Now this layer is going to check after every 10 pages that whether the previous pages were received, and if they were not, then is going to send that this page is not received, retransmit it. Okay, this will be synchronization, and this is done by session layer. Now finally on the transport layer, this layer is also known as the HERT layer. Why so? Because it is responsible for process to process delivery. I told you earlier that this layer provides the data with port addresses. So what port address is? It is application's address. Now application is termed as process here. So it is responsible for the communication between application to application, that is process to process of entire delivery of entire message. All right. Now that is from application to application, as it provides the data with port address, as I earlier told you. Now services that this transport layer provides, it is quite an important layer of this OSI model. And the services port address, as you already know. And the second one is segmentation and reassembly. Okay, segmentation you already know is that giving us breaks a big message into smaller data and numbers them, so that the other computer's transport layer can reassemble them, the smaller data. Okay, so basically it says whenever you are transmitting some data, it will be provided with some sequence number. So whenever the other data layer receives it, other computer's transport layer will receive it, then that layer will rearrange that stuff according to the sequence numbers. Then connection control is another thing that it does. It will provide both connectionless and connection oriented services. All right. Now end to end, that is flow control. You already know what flow control is. Let me elaborate it to you one more time. Basically, this is a speed controlling mechanism to match the sending speed and receiving speed of both the devices in order to prevent data loss. Of course, I told you now, if you have 3 MB per second speed and I have just 1.5 MB per second speed, now you are sending me the data. If you are sending me on 3 MB per second, I am only receiving 1.5 MB per second. So whenever you are sending me 3 MBs, I am just receiving the half. And again you are sending me 3 MB. Again I am receiving the half. So this will end up making the communication unsuccessful. The data can be lost somewhere. Hence flow control is quite necessary, and this layer provides flow control. With that, error control is also provided. In error, it's going to check whether whatever the data transport layer provides is checked for errors, if any error is there. What errors are, what could be, we are going to discuss it all later. First, just let's know that it does error control. Of course, because we don't want to provide the receiver with error data, right? And this was all about transport layer. So it does port addressing, it does segmentation and reassembly, it does connection control, it does flow control and error control too. Moving on to the next layer, that is network layer. Now this layer is responsible for original source to destination network. That is, it provides IP address. Now basically this network layer will be helping in routing, because the routers are actually going to find the route with the help of IP address. As I told you that your computer is first recognized as a LAN, as a part of LAN, and the router, whatever the router is sending you, will first send to your LAN, then it will reach you by the help of MAC address. So this helps in first of all logical addressing, because it provides IP addressing. Then routing, as I told you just now, as it provides the routers with IP address of both the computers. This helps the router to find the best route for transmission. All right. Now at last, this second last layer, data link layer. What data link layer does? It moves data frames from one node to another node. Okay, so whatever the upper layers has provided this layer, it's going to make frames of them. Okay, and then we'll move those frames to one node to another node. It provides MAC address. Now services that provided by this layer are framing. I earlier told you that it groups the bits of 0 and 1 that are being provided by the upper layers into frames. We are going to read about framing in quite a depth, so just don't get bothered with this. Now physical addressing, it provides MAC address, so that's why it's termed as physical addressing, is also a service provided by this layer. Now flow control and error control are similar to transport layers. Alright, so the flow control there and error control are also done here. Access control. If there is a common communication link that is being used by 3 or more computers, then data link knows which node is accessing the link at present time, and data link layer decides which will be the other computer to use the link after the first one is done. Suppose there are 3 computers using a single communication link. Now this layer will be having the knowledge that which computer is currently using this network, and once it is done, then this layer is going to decide which will be the other node who is going to send the data. Alright, at last we have physical layer. Okay, now what physical layer is? Basically physical layer, we can say that physical layer is just the medium. It's just the medium where you are going to drop all that data. What it does is the zeros and ones that you were uh, provided by the data link layer, it's just going to convert them into signals if that is a wired medium, and into waves if that is a wireless medium. Alright, coming on to the definition, it's also written it transmits bits over a medium. Bits, that is 0, 1, 0, 1 and all that. Bits over a medium. It also converts these bits according to the medium. This is what I earlier told you, signals a wired medium and waves a wireless medium. Now services provided by this layer are, there are quite a lot of services. Physical characteristics of media, that physical characteristics is basically wired or wireless. Alright, then representation of bits. Now these bits are encoded into signals. Alright, so this is representation of bits as signals. Data rate, number of bits sent per second, what is the speed of the data being transferred. Synchronization of bits, the sender and receiver's clock must be in sync. Alright, so this also takes care of this stuff. Then line configuration. If the connection is if the connection is among two nodes, a line is dedicated to them. However, if there is one to many, then multiple nodes access the common medium. So basically, suppose if there is just one computer to one computer, then the line configuration has no problem with that, because it's just among two nodes being the connection is just among two nodes. However, if the connection is among several nodes to one node, then this thing knows that how many computers are there and takes care of that stuff. Alright, lastly, physical topology. We read about topologies, so it also knows what type of topology here is being used. Okay, and transmission mode, whether the transmission mode is duplex, half duplex or simplex. So yes, this was all for today guys. I hope you enjoyed this session. Thank you guys.